And then I'll maybe give you a slightly more detail about, depending on how much time we have for lunch, about a software library that we've built in our lab, which is a small library that helps you build outdoor air applications quickly. So maybe I'll give you a little bit more detail about how to use that library, and then maybe that will be it. And hopefully we'll finish 5 or 10 minutes before 12 so that we can clean up this space a little bit for lunch. Okay. So first of all, this is a website. I'm not sure if you have had a look at this website. I'm pretty sure if you try to launch that website, it will not connect. Or yeah, but it looks like this. This is how it looked like this morning. Before, unfortunately, our web server got hacked a couple of days ago, and our IT manager is currently going through some management stuff. So it's a bad timing, but at least I had this loaded up this morning when it was working, and we have a couple of projects or tips you can look on our website, this Air for Glass website, and have a couple of demos, actually some APK files you can run on either on glass or on a smartphone, Android phone, so you can quickly glance how these type of AR libraries work on glass. So let me just show you a couple of demos that's available on our website, although the website is down at the moment. So if you go to our website and go to the projects, I will not bother clicking it. There will be a couple of projects that shows up, that explains, that has some sample APK files that you can run on glass, and that uses AR libraries. And one of those is using this NIR toolkit. If you type just NIR toolkit in Google, I'm pretty sure this will be the first page popping up. And this is Java-based AR toolkit, which uses this type of square markers. And you can, since it's written in Java, and it's actually a port of C++ version of AR toolkit, which Mark did his PhD on it. So since it's a Java version, you can easily run on Android, and they provide an Android version of NIR toolkit as well. And it's quite simple library you can use. If you're interested, you can try that one. Let me show you it running on the glass right now. And if our website was on, then on the website there should be all the command line commands that you can use, ADB, which is included in your Android SDK to install the APK file and to run that. But glad that I have a copy of those here. So first we'll install. Just to quickly explain, it's in ADB. You can type ADB install and then NIR toolkit APK, and it will start installing that APK on our glass. Unfortunately, this sample application we didn't modify anything, which was available on NIR toolkit's website, so it doesn't have a voice command. So to run the app without voice command, you'll have to run this command, which is am start. And I'll turn the glass on. Then it's running now. I forgot to run this screencast. Okay. So as you can see here, the frame rate is quite slow on this screen, but it's not too bad on the glass. If I print out this kind of square marker and try to look at it, you can see it overlays a kind of OpenGL cube on top of this square marker. So as you can see here, Nair toolkit quite works well on glass as well. So if you're interested in doing some kind of AR application that runs on a desktop setting with some markers, then that's a good library you can use. The other library is more widely used this day, which is Vuforia, Qualcomm's Vuforia library. And this is their website. So, and they have quite an advanced technology, such as detecting these kind of photos that has rich textures, or recently they've got some more improvement that you can actually track. You can start tracking from the marker, but you can also go away from the marker, and will still pick up some image features from your environment and keep tracking. Just run. And the demo I'm just going to show you is just a plain sample code upstairs, and Vuforia. And this sample APK, we've built it and uploaded on our Air or Glass website. So if you want to try it without building it, you can do that. It's virtualbuttons.apk. Then, and all these ADB comments are on the website as well once it's back. It's virtual buttons. Stopped. All right. So again, it will start with picking up some camera image like this. Then if I look at a piece of paper that it's programmed to track, as you can see here, I can see a teapot. And then you can also tap on some physical buttons, the virtual buttons that's overlaid on top of this marker. So you can point at some buttons, and the color of the teapot will be changing accordingly. It likes the yellow color. But anyway, as you can see here, these types of, as you might have already expected, these types of libraries works pretty quite well on Glass as well. So if you plan to have these types of desktop-based AR applications, then Vuforia or Nair toolkit might be a good starting point, so that you can build your application and test it on your phone, and later on you can easily run that on Glass as well. So that's our AR for Glass website. Hopefully it will be back later today. And the main thing I'm going to talk today is our Outer AR framework, or software library that we have available on our website. This is our link to that page. You can download for free, and it's an Android library so that you can use it, and it runs both on smartphones and Glass as well. So you can start building some AR applications, especially outdoor AR applications, which uses GPS and sensor information to overlay 3D graphics in the real world. So how many of you have tried one of the AR browsers on the smartphone? Yep. Anyone? So, since the smartphone came out, the iPhone and the Android phone, people started building this type of AR browser applications, which overlays tags or simple 3D icons in the real world and roughly tells you where about the things are, although it's not super accurate compared to these types of computer vision-based tracking. But since we cannot really track everything outside, these types of applications have been gaining some popularity, although it went down to that technology hype curve that Mark mentioned. Anyway, we can easily do this stuff on these kind of browsers. These browsers does provide some APIs or libraries by themselves, but they're quite limited to run those contents on their own browser so that you cannot really do customization with the interface of your app and sort of things. So what our library, the Outer AR library provides is more flexibility so that you can customize the user interface and you can build in your own application logic so that you can build either a game or a information browsing type of application and sort of things. So it's more flexible, I would say. So these are some of the applications we've built our library with our library, and some of them are available on Android Play Store. So if you're interested, you can download it from there and try it out on your. Why is this wrong color? This is showing in wrong color. I'll try to run it again. It's totally wrong. Maybe my laptop is struggling with low memory. I'll just go to folder. Try to run it here. Run control ctr. Let me actually run this video clip, which shows it running on Google Glass, although it's quite similar to the version. So as you can see here, this is, by the way, Cashel Street, down the city center of Christchurch. And in Cashel Street, many of the shops are, the buildings has been demolished and the shops are now replaced with these types of container boxes with shops inside. So what CityVR does is it shows 3D models of the old building, as you can see here. This is the screen on the glass, and kind of show roughly how that street might have looked like before the earthquake. So, and as you can see, as the user turns his view, it shows the name of that building or the address of the building that used to be there. And if the user taps one of that building, it will show you some more information or historic stories about that building, so that user can swipe through or use their head to scroll through the page. And then once they're back, they can also view some panorama pictures. In this case, you can pick one of the icons on the real world that represents panorama pictures, and it shows the panorama picture taken right after the earthquake at the same spot, so that you can see how that street might have looked like right after the earthquake. And this is another example showing the big building that were used to be at the corner and which is now just empty space with a car park. So that's a type of application we can think of. I'll show you just one more example, which is a kind of game application. And this is this was originally designed to run on glass, but this video clip is just running on a phone. So this is an app. It's a kind of location-based gaming app, and we kind of designed it to be encouraging some walking outside. So it starts with the map view, and it shows your location, and it makes some sounds, beeping sound. And as you can see here, it shows some icons of these mysterious creatures that you can find there. And as you get closer, it will make more frequent beeping sound. And as you get to that point, let me scroll. And then it will say you found a flock of geoboys, and it will start an AR view. As you can see here, you'll find some big creatures flying around, and you can actually capture them. We didn't want it to make a violent game, so we made a concept of capturing them. Originally, we was thinking of throwing a net with this glass pad, so we can, although we are swiping on a screen, on the glass, it should work like swiping on the touchpad, and you'll throw a net, and then you can capture them back. But we're still working on that one. And the other thing we were thinking of was to integrate some more cool interaction that we can think on the glass. So one was using voice input. So what we did was we kind of made a small pitch detector, so that when people whistle in a correct pitch and in a correct length, then the geovoice will get scary and then flock together. So let me show you to make it easier to capture. So let me scroll a bit further. It was somewhere here. Yep. So as you can see here, here's a small meter showing how well you are whistling. I think, where's my mouse? So it will show you how good you are whistling. So it's too high. And then they will get scared and then get together, and you can easily capture them. So, and the other, although we haven't still implemented it, the other idea we had and we are trying to implement is them attacking yourself. So your screen will be filled up with some either some goozy things, and then you have to shake your head to take over them. So that's kind of example applications that you can build with Outer AR framework. And as you can see here, you can pretty much customize whatever you want on the screen and the way you interact and the flow of the application logic. So it's quite flexible compared to other libraries that are out there for Outer AR. So I'll just briefly go through some of these, some of the details, and then maybe show you one demo that outlines how to code it. Then, so we have a kind of library that runs on the client side, but what we also have is a server-side code so that you can deploy content on the server and even set up your own server and deploy content through that. And the server software kind of gives you a RESTful API interface, and it also comes with a web-based authoring tool that looks like this, so that users can easily drag and drop 3D models onto the map and type in some descriptions of it, and it will appear on the and either your application or some standard browser application could load those 3D scenes. On the client side, it provides an abstraction of not only AR, but also the map view and the list view, which is quite common on Outer AR browsing applications. So you can use the same underlying scene data this map and list view will easily take those same data set and load up without any coding in the Android library level. So it's a little bit handy when you're building like the GeoVoice. You can easily use both map and AR view components so that you can integrate them together. So with customization, you can customize each scene. So we have a class called OA scene, Outer AR scene, that basically has a name and description of string, and then you can describe the latitude and longitude of scene, and then you can add a 3D model and it will appear at that place. But the good thing is that you can actually extend that class and add your own data structure to that, so that you can use, if you are building an Outer AR application for zoo or something animal, then you can add some data structure telling about that animal or a plant or something. So that's one thing you can do with Outer AR library. And the other thing is you can highly customize the user interface layout by yourself. And the way to use this library is as simple as creating an Android project, and then our library comes as an Android library, so you can easily add that to your project. And then maybe I'll just briefly show you how to do that right now. And then, so we'll start with a Eclipse project. And by the way, the library itself and the sample code I'm going to show you now is all out on the shared folder. And also, the library itself is also downloaded from our website, but it's down at the moment. So if you open up the Eclipse, Let's take it to build something. All right, then what you can do, of course, you'll have to download those library in the source code. And what I'll do is just simply import. Oh, by the way, the first step, it has some dependency on the Google Play service because it's also using the map library that's provided by the Play service by Google. So the first step you'll have to do is import that Play service. And the way you can do is you can go to import and then choose Android, existing Android code. And then in your SDK folder where you installed your SDKs, for in my case it's dev.lib and edit bundle. Inside the SDK there is a folder called extra, and there's a folder called Google Play Services, and they kind of taken away this map component out of the standard Android SDK and providing it as a Play Service library. So, and then go to lib project and Google Play Service.lib and then choose that one. And it's a good idea to copy it instead of building it in place, not to ruin the original source code. And then you'll have that library in, and that's all. Then now you can import the outer area library, which is, if you have downloaded it, you can click existing projects, then click next, and go to, I think I had it in download, outer area, and if you have downloaded, unzip it, your folder might have two of them, so you first import that library. And then there is one more dependency that you'll have to add, which is the Android support library, which again has to have for the map UI. So for that, you'll have to go to, again, dev.lib, that's where I put my Android bundle. Inside the Android SDK, again, go to extra, this time Android support, and there should be a folder called B4. There should be a jar file there. So you can drag and drop this file to the libs folder of the library. So, okay. And by the way, these steps are all explained on our website, so don't worry too much about setting up. So once that you've got those dependency libraries running, then the other thing you can do is import the sample code, which was right next to the outer area library, and run it. And this sample code has all the sample components, including the list and AR and map, and shows how to use them. And this is on our website, so I'm not going to explain that one. But coming back to our website, so that's how to set up the development environment. Again, those are available on our website, so don't worry too much about it. And when you're building your own project, there are a couple of things you have to be aware of. And one thing is, again, permission. So if you're going to use GPS, again, as I mentioned yesterday, you need to state that your app is using access to GPS locations in the Android manifest file. And also, the other thing you'll have to be aware of is that our library also accesses some cell information. Let me show you actually what the manifest looks like, the sample code. So these are the permissions that you need to run Google Maps based interface, map interface. And these are the permissions that you would need to run. It's basically accessing locations and the camera so that you can show the camera background. And this is for keeping the screen on and not timeout when you're not active. So, and one thing is that you'll have to inherit your activity from OAAR component base, which is a class we provide in our library instead of the standard activity class in the library. And once you've inherited that, this class will provide you with handling most of the Android side things so that it will be easier for you to implement an AR application. So another thing, you'll have to prepare 3D models. Currently, the library can load OBJ models, and I think there is another type of model called Q something. I can't recall at the moment, but it's described on the website, so please refer to that one. And it uses OpenGL coordinate system, which is just like this in the real world. And the -z direction is pointing to the north, so it should be that way, like this. So if you place on a model in certain lat long, and if you load up something, a 3D model, then that you modeled on your modeling package, such as Maya or Blender, which is a free one, then the XYZ coordinates should look like this. And placing it on a real world, this website is quite handy, where you can actually just click on a map, and it gives you back the latitude and longitude of that place. So this is that website. So if you click on certain place and then click that, then you can simply copy that and copy to your code. So that's handy. So and then you add that to your assets folder in your project, and name your model in a folder, and then put the OBJ file. And what you have to override this time is on setup scenes is where you can add scenes to your application. On scene selected is when it will be called back when user taps on one of the scenes, and you'll get what scene the user has tapped. So you can do something like showing more detailed information, or like in the GeoVoids game you've seen, we are just simulating the tapping event and getting which GeoVoid was tapped on and kill that one. And okay, also you can use some of the functions we have in our libraries, which you can mark your location to certain places so that you can test your application as well. So you can describe the scene by code either or using SQLite database file or XML. So you can easily change your scenes without changing your code. Again, OA scene is a class that describes the scene with, you can describe lat long and 3D model sort of things. I'll go through those. And to use the map interface, you'll need the map API key from Google. So that's the place you can get those. So I'll just show you a project that I've put together for this tutorial and explain a little bit more detail, and then just show you that running on the glass project. Then this code is up on the shared folder again. So it's tutorial, no, glass class, tutorial projects, and it should be called OA tutorial. There we go. So don't worry about the main activity. This was for demoing purpose. So as you can see here, the OAR component base itself overrides other methods such as onCreate and sort of things. So it handles putting the layout for you. So you don't really have to override those in case you're building this app. And instead, you might want to override some other functions that the library provides so that you can set up your scenes, like creating a new scene objects and then putting a lat long and the name of it, and then add it to the data manager, which was passed to yourself, so you don't have to worry about setting those up. The library does everything. And you can also override on some methods, like such as on touch scene method, which is called back with the scene that's touched on, And then you can either give a toast message, or in this case, we change some text on the info panel text, and then and show the name of that scene, sort of. And in setup UI callback, you can set up your own UI layout. So if you want to add some labels on the screen, or in this case, I think I had some reticles so that you can aim at the scene while you're running on Google Glass. So you can define your layout in the XML file as you normally do with your Android project, and then just load that and tell the library that you're going to use that layout. Then it will be overlaid on top of the AR background. And other things you can do is to make it more friendly to run on Google Glass, you can run a kind of background timer and kind of simulate as if you are tapping on the middle of the screen, so that you can get the scene called back to your on touch scene function while you are aiming at it. So let me just run this one on Glass and just show you how it runs, and maybe we'll wrap up this session. So click run as Android application, and hopefully it will not complain with any errors. Hello. Still launching, still launching. It's building. There we go. I go back here. So as you can see here, I made it to start. I just stuck. Got kicked out. I think I made it to run it without the background. Setup options. Just try to run it again. It's not showing the camera. Maybe I'll have to reboot this class. Can I grab that white one, please? I think something I ran with the other AR demo, it's kept holding the camera. So I'll do it here again. So to run this one as well. It's running on my glass, but stopped showing on the. So as you can see here, it will have a camera background, and if I look around, there should be some icon somewhere. Maybe better this side. So if I look at the cube, then it will show that that is a cube. If I look around, there should be another cube there. Then there's a small basketball flying over there. So as you can see here, you can write quite easily an AR app that could run on Android devices, including Google Glass. So couple of tips. It's again, it's easier if you rather make it to aim to select it rather than required to tap something. So the thing is, as I've shown you in the code, you can run a timer and force to have a clicking event at the middle of the screen, and that could do the trick. And on generic motions, you've already have been playing with this, so I won't mention too much. And you can also think of head motions, as I've explained earlier, with geovoids. And again, GPS on glass is not available, and you'll have to pair it with the phone. Other thing you can do is use on the application you can use a mock location, and then what you can do is write your own application that streams the GPS location from your phone through Bluetooth, and it's quite easy. And here's a link to a sample of where you can grab a sample code of having a Bluetooth chat sample for Android. So if you modify a little bit, then you can easily stream whatever data you have on your phone to the glass easily. And that's what we actually did with the city viewer for that. So let me just briefly show you how city viewer looks like on the glass, and maybe we'll finish today. So I've keep closing this. And by the way, this city viewer APK is for the glass is also available on our Air for Glass website. So, OK Glass, city viewer. So it will start with looks quite similar to the other sample I've shown you. I think it's still loading some building models, so that's a bit responsive. You can either turn on the camera or turn off. In this case, I'll turn it off because it shows you more clearly what buildings are around. If I turn around, you can aim at the building and it will show you what building it is. And if I turn this way, I can find some icons floating up there. So if I aim at it, it will say panorama. If I tap on my touchpad, and we'll load up the panorama picture that's taken at the same spot. So you can look up or look down and turn around and have different look at the place. So that's City Viewer. It's again developed using the same library. So that's it for today. If you have any questions, maybe just ask me or just talk to me over the lunchtime. And I think both this one and this one has City Viewer on it. So if you want to try yourself, just say, OK, Glass City Viewer, and we'll load up. And that's all for the lecture. And maybe after the lunch, maybe you can start preparing some screen captures of your app. I'll show you after lunch maybe how to do that and help you to do that. And maybe we can wrap up this session today. So thank you. And let's maybe, I think we're going to put food in this desk, so maybe